Hi everyone, and welcome to our video on the law of cosines. So the law of cosines will find a missing side or a missing angle. It works when the law of sines does not work. Okay, so one of these will always work to help us find a missing side or missing angle. Um, Unless they give us like bogus information like we might have saw from the law of sines where there was no triangle at all. But these will always, one of them will always help us. Okay, remember if it's a right triangle, just use SOHCAHTOA and Pythagorean's theorem instead. Okay, but the law of cosines, the way I look at it, I think of them, so there's three different formulas, and all of these, okay, so if you're curious where they come from, it is, so I have this triangle here, it is by using SOHCAHTOA and Pythagorean's theorem with manipulation on this triangle. But that would take a while. So if you are curious about the proof, I mean, there's certainly YouTube videos where you can double check to see how they break it down. It's not too bad. Or let me know, email me. Okay, but for us, we're just going to say, hey, these are the formulas, and they're all the same. Just the letters are rearranged. The way I think of it is I look at this part and I say, well, that's just like Pythagorean's theorem. Okay, so a squared equals b squared plus c squared. Again, the letters don't matter, so but I still think, oh, it looks like Pythagoreans. And then I say, well, I have two letters right here, so I need to minus 2, and then those same two letters, BC, so minus 2 BC, and then throw a cosine of the final angle that matched the first letter, but as an angle. Okay, so these end letters are always the same, just one's a side and one's an angle. Okay, and it works the same way for all of them. So I think, oh, here's Pythagorean's theorem. And then I need to minus these same two letters. So minus 2 AC. And then law of cosines, I should have a cosine. And then again, the last letter is the same as the first letter, but one's a side, one's an angle. And then the last one, still same thing. This looks like Pythagorean's theorem all the way with the normal Pythagorean theorem. C squared equals a squared plus b squared. And then minus these two letters, minus 2ab. And then cosine of the first letter, but as an angle. Okay, so that's how it works. Now let's see it. So let's break down this problem. We're going to find a side. So find side A for the triangle with A equals 45 degrees, B equals 4, and C equals 8. Okay, so often they want you to solve for everything. Solve for the triangle, which is finding all the angles and all the sides. On these law of cosines and law of sines problems, unless it's like a story word problem, I usually don't even worry about a picture. Here I am just going to list the information. So I've got the capital A is 45, and then I have B is 4, and then C is 8. Okay, and on these problems, so we're in the law of cosines section. We just introduced the formula, so it's going to be a law of cosines. But say you're trying to take a test, and they're not going to tell you which one to use, most likely. I would try the law of sines first. Okay, so this is not going to work, but I'm just rewriting it out. Here's our law of sines. And then I would plug things in and see, well, what's going to happen. And I have sine of 45 over A equals sine of capital B over 4 equals sine of C over 8. And then I look at all these and I say, well, none of these fractions are completely full with information. Law of sines only works when I have one of those happening. So that means this is a dead end. So no matter which two I set equal to each other, I'm going to have two unknowns. All right, so this is no good. So law of sines is no good. But moving on, law of cosines should work. Okay, so we're trying to find side A. And really that's the only option for us anyway in this problem based on this information. So we'll find this side A. So you could try any other formula, and if it doesn't set up with only one unknown, that means, well, we got to try a different formula. All right, so we'll do that top one. So again, I think, all right, it looks like Pythagorean's theorem, a squared is b squared plus c squared. And I pause for a second and then I think, okay, minus those two letters, minus 2 BC, and then cosine of the first letter, but as an angle. And then we'll plug all that in. All right, so we've got a squared is what we're trying to find, or a is what we're trying to find eventually. B squared, we would have 4 squared, plus c squared is 8 squared, minus 2 times 4 times 8. and then cosine of 45 degrees. Okay, so we subbed all those in, and then now we'll work our way through it and simplify. We've got a squared equals 16 plus 64 minus 2 times 4 is 8 times 8 is also 64, and then cosine of 45 degrees. And then so cosine of 45 degrees we can do without a calculator. We can do the unit circle, so that's the exact value part. But let's simplify the rest of this before we do that. So 16 plus 64 is 80, and then minus 64 cosine of 45, like that. Okay, one mistake, so don't do this. So don't say, oh, 80 minus 64 is 16, and then cosine of 45 is attached. No, don't do that. Okay, so it's just like if you had, so side note, just like if we had 80 minus 64x. These don't combine. Okay, so the trig function, it acts like a variable in this case, or you could still say, well, they're definitely just not like terms. This is just 80. This has 64 cosine 45. We can't combine them. They're not just regular numbers right now that could be combined like normal constants. Okay, so don't do that. Don't do that. So that's bad. So leaving that up there. Okay, instead, if we want to finish this answer before evaluating the trig function there, we could square root both sides. Now, when you square root, again, for habit, plus minus, but since we're finding the side of a triangle, it would automatically be positive. So we would have a is equal to the square root of 80 minus 64 cosine of 45 degrees. And make sure that big square root goes the whole length there, just like mine. Okay, so the reason I'm writing it like this is if you can't use a calculator and they give you an angle that you can't do, say like it's cosine of 40 degrees or cosine of 32 degrees or cosine of 17 degrees, then this is how the final answer would look. So this would be writing it using the trig function without evaluating the trig function. However, we can do it without a calculator still. We can evaluate. So we will, let's do it. So we've got cosine of 45 degrees is the square root of 2 over 2. And then we could say, oh, 64 and 2 would divide. They would simplify. So we would have a is equal to the square root of 80 minus 32 square root 2. Okay, so this answer is writing it using a trig expression. Enter in terms of trig expression, which again is the way that we would do it if we can't use a calculator and we can't do that angle from the unit circle. So like if it, again, like 20 degrees, 27 degrees. Okay, so if it's 30, 45, 60, 120, then we're doing those. Okay, and then this is the exact value answer as far as we can go without a calculator. So this is the exact, so it says exact answer, but they usually say exact value. That's the exact value answer. Okay, so there's the two that they want. And then now, well, we could plug that into the calculator or either one of them to get the decimal. So we also need to write it as a decimal rounded to the nearest tenth. Okay, so I've just used Desmos because we can write it exactly the same way as we see it there, like that. Okay, so there it was. So 80 minus 32 square root of 2 is 5.9 to 1 decimal to the nearest tenth. Okay, so we'll even do that. Okay, and it said it was in feet. I guess we could put feet. Let me put those there, feet. Okay, so there we are. So we have them all. We have all the sides now. I am gonna just write it in blue here to say, well, here is the 5.89 feet. If we did have to solve for the whole triangle, we can now find angle B and angle C because we could go to the law of sines. Look at this, that A is now known. So now we have a complete fraction and we could set this up to solve for angle B. And once we have angle B, we can get angle C because triangles angles add up to 180. Okay, so if they did ask to say solve the whole triangle, we got it now, or we could. Okay, but at the same time, I'm gonna say, well, we could do it, but let's stop so that we can move on. Okay, so that's it. That's how we find the side. So thank you for watching. If you have any questions, please let me know.